dashing through the snow in a one-horse open sleigh.
Problem number 9 asks what must be true for a number to be expressed in scientific notation. And the answer to that is it must be expressed as a product of two factors. The first factor must be greater than or equal to 1 and less than 10. The second factor must be a power of 10. So here's an example. 2.8 times 10 to the negative third power. This first factor greater than or equal to 1 and less than 10. The second factor is a power of 10. Problem 10 asks us to find the unknown lengths and round to the nearest tenth. So we'll use Pythagorean theorem because these are all right triangles. In this first one, I know the two legs, so I know A and B. Start with the formula a squared plus b squared equals c squared. A is 2, so 2 squared plus 9 squared is equal to c squared. 4 plus 81 equals c squared. 85 equals c squared, so c equals the square root of 85. And the square root of 85 is in between the square root of 81, which is 9 wholes, and the square root of 100, which is 10 wholes. It's 4 away from this perfect square, and the distance between these two perfect squares is 19. So it's 4/19ths of the way between these two wholes. And not exactly, but that's a good way to estimate. So we want to know, this is 9 point something. We want to know what 4/19ths is. So we find that by dividing 4 divided by 19. How many 19s are in 4? 0. But then I just reveal the decimal and the 0 in the tenths place. That's still 4. 4.0 is equivalent to 4. Line up a decimal in my quotient. How many 19s are in 42? Because 2 19s is 38. We're rounding to the tenths place, so I need to go up to the hundredths place in order to do that properly. I'll reveal the 0 in the hundredths place and bring it down. There's 1, 19, and 20. Don't need to go any farther than that because 9.21 rounded to the tenths place is just 9 and 2/10. You should always put that dimension on your triangle when you're done. That hypotenuse is greater than either of the legs, but not to a ridiculous extent where it would look unreasonable, so that looks like a good answer to me. This next triangle, in this case we have the hypotenuse and one of the legs. We'll start with the same formula, Pythagorean theorem, a squared plus b squared equals c squared. I'll just call x a, so x squared plus 5 squared equals 7 squared. So x squared plus 25 is equal to 49. Subtract 25 from both sides of the equation to isolate x squared. So x squared equals 24. Then I take the square root of both sides to get x. X is going to be the square root of 24, which is very close to 25. Square root of 25 is 5, so this is probably going to be 4.9, but just to be sure, we'll go through the same process. The next perfect square below 25 would be 16, that's 4. Square root of 16 is 4. And so 16 is 16 to 24 would be a distance of 8, and 16 to 25 would be a distance of 9. So we're really trying to figure out what 8/9 is. 8/9 is 8 divided by 9. There's 0 9s and 8. There are 8 nines in 80 because 8 nines is 72. Subtract and I get a difference of 8. Show 0 in the hundreds place and bring it down. There are again 8 nines in 80. So actually you may have recognized that we know that 1/9 is 0.11111 infinitely, and then 8 nines is just 0.8888. So 4.8 repeating, 4.888 rounded to the tenths place will be 4.9 as we predicted. So 4.88 rounded to the nearest tenth is 4 and 9/10. And when I put that on my triangle, the two legs are less than the hypotenuse. The sum of the legs is greater than the hypotenuse. All of that looks reasonable. This final triangle, again, we have the hypotenuse and one leg, but not the other leg. Don't forget the legs form the right angle. So even if the hypotenuse is shown horizontally like it is in this picture, it's still the side opposite the right angle, so it's the longest side. So C is 32 in this case. We can call this A and we can call this B. So A squared plus B squared equals C squared. 20 squared plus X squared equals 32 squared. 400 plus X squared equals, I don't have this one memorized. This is 64 and this is 96, so I should have had it memorized. That's okay, 10,024. Subtract 400 from both sides. And I get 624 here. And here I get X squared. So X is going to be equal to the square root of 624. I happen to know that 625 is 25 squared, so I think even when we round this one, we're still going to get 25, but let's do it the way we've been doing it. Square root of 624, the next perfect square above it is square root of 625, which is 25. The one below it would be 24 squared, which is 576, if I remember right. And so 576 to 624 is 48. 576 to 625 is 49. So this is 24 and 48/49. You know, we could do the division, but you could really multiply this by 2 halves and see that it would be 96/98, which is, this is so close to 100, so we can just really go with this 0.96. And this rounded to the nearest tenth, this 9 would become a 10. And so really, even when it's rounded to the nearest tenth, it's still 25, 25.0. And so this this other leg is 25. The two legs are smaller than shorter than the hypotenuse. The hypotenuse is shorter than the sum of the two legs. All of this looks reasonable. Problem 11, we need to solve the equation by identifying the variable value. Once we've identified the value of the variable, we'll substitute it back into the original equation to verify. I don't want to know what 2m plus 15 is. I want to know what 2m is, because once I know what 2m is, I can find what 1m is, and I'll identify m that way. So I need to get rid of this constant term first by subtracting 15 from both sides of the equation. That's property of equality. This difference is 16. And this is 2m plus 0. That's the additive identity. That's the additive inverse. When you add opposites, you get a sum of 0. This is the additive identity. 2m plus 0 is 2m. And then we'll divide both sides by 2. Again, property of equality. 2 divided by 2 is 1. When you multiply reciprocals, dividing by 2 is the same as multiplying by a half. So when you multiply reciprocals, you get a product of 1. That's the multiplicative inverse. So 1m equals this quotient, which is 8. And so m equals 8. 1m is m. That's the multiplicative identity. So we think m is 8, but let's substitute it in to make sure. 2 multiplied by 8 plus 15 should equal 31. 2 8s is 16. And the sum of 16 and 15 is 31. So m is 8. Problem 12. It says if 5 cubed plus 5 cubed plus 5 cubed plus 5 cubed plus 5 cubed equals 5 to the n power, where n is a positive integer, what is the value of n? In order to solve this one, you have to recognize that you have a situation here where you have repeated addition. And so if I had, for example, if I had 7 plus 7 plus 7 plus 7, that would just be the same as 4 times 7. Well, here you have 5 cubed plus 5 cubed plus 5 cubed plus 5 cubed plus 5 cubed. So that's the same as 5 times 5 cubed equals 5 to the n. And since 5 is 5 to the first power, if you remember your rule for multiplying with the same base number, you just add the exponents. So that's 5 to the 1 plus 3, or 5 to the 4th, equals 5 to the n, so n must equal 4. Okay, that completes page 3. We'll conclude the review with page 4 in the next video. Thanks for watching.
Laughing all the way. Bells on bobtails.